What is dynamic programming? Dynamic programming is a problem-solving approach that involves breaking down a complex problem into smaller subproblems and solving each subproblem only once, storing the solutions and reusing them to solve larger subproblems. This technique is particularly useful when the same subproblem is encountered multiple times in a given problem, as it saves computational time by avoiding redundant calculations. Some examples of problems that can be solved using dynamic programming include Fibonacci sequence. The Fibonacci sequence is a series of numbers in which each number is the sum of the two preceding ones, starting from 0 and 1. This can be solved using dynamic programming by storing the solutions to the subproblems of calculating each Fibonacci number and reusing them to calculate larger Fibonacci numbers. Longest common subsequence. Given two sequences, find the length of their longest common subsequence. This problem can be solved using dynamic programming by breaking it down into smaller subproblems and storing the solutions to each subproblem in a table, which can be used to solve the larger problem. Knapsack problem. Given a set of items, each with a weight and a value, determine the maximum value that can be obtained by selecting a subset of the items that has a total weight not exceeding a given limit. This problem can be solved using dynamic programming by breaking it down into smaller subproblems and storing the solutions to each subproblem in a table, which can be used to solve the larger problem. Sample problem. You are given an array of n integers. Find the maximum sum of any contiguous subarray of the array. Solution using dynamic programming. To solve this problem using dynamic programming, we can use an approach called Cadon's algorithm. The key idea behind this algorithm is to calculate the maximum sum of any contiguous subarray ending at each position I in the array, and then find the overall maximum among these sums. To implement Cadon's algorithm using dynamic programming, we can define an array dp of length n, where dp, I, stores the maximum sum of any contiguous subarray ending at position I in the input array. The maximum sum of any contiguous subarray in the array is then the maximum value in the dp array.